Chapter 7, Problem 12. A can of bolts and nuts are pushed 2.0 meters along an x-axis by a broom along a greasy, frictionless floor of a car repair shop in a version of shuffleboard. Give the work done on the can by the constant horizontal force from the broom versus the can's position x. The scale of the figure vertical axis is set at Wx equals 6.0 joules. A. What is the magnitude of that force? B. If the can had an initial kinetic energy of 3.0 J moving in the positive direction of the x-axis, that J is for joules, what is the kinetic energy at the end of the 2 meters? This is it's not a hard problem at all, even though they give it 2 stars. We know that work is equal to force dotted with distance. In part A, they want to know what is the magnitude of the force, so we're just going to solve for the force. That'll be force is equal to work divided by the distance. And we know the work is 6.0 joules, that's the height. So 6.0 joules divided by the distance, 2 meters. Joules divided by meters is going to give us newtons, which is going to be 3.0 newtons. So part B says if you had an initial velocity, had an initial kinetic energy of 3.0 joules, and it goes the full 2 meters, what is the ending amount of kinetic energy? Well, the kinetic energy is going to equal the same as the work. So if we have 3.0 newtons from the work, we just do this. Okay, so we have 3.0 joules initial plus the 6.0 joules that's in the system. It's just going to equal 9.0 joules. It's not too much to say about this problem, so that's B.